Well, hello. So last time what we did was symmetry of a equilateral triangle, if you remember. So let me draw the thing first. Okay. I will just quick recapitulation for this thing. This is an equilateral triangle. If you remember, symmetry is something like from a view, you will see exact same copy. For example, in this triangle, if you remember, I will again revise it right now. If I draw this perpendicular, what is a oh, you don't know perpendicular, right? So what is a perpendicular is that uh, this is a line, the thing which is totally straight. This is a perpendicular. You don't know have to understand what is it right now. Just see this. So across this line, when you see towards the right, like for example, like put a mirror in this line. Okay. So when you see like this is your eye here. Okay. So when you see from here, you will see that this equilateral triangle will be, the image you will see will be exactly same as this triangle. The reason is because since this triangle and this triangle and this triangle, let me use the different color, red. Okay. And this triangle exactly being same, the mirror will form mirror image of this triangle. Okay, of this triangle, which will be present here, and you will see it. Okay, so that's why you will see the exact same. So let me just wipe this thing for now. This is one such line. Now again you can draw this line here, which will again form exactly same symmetrical structure when you put a mirror through this line. So again you can draw this line and this line. So for this figure, there are three such symmetry, axis of symmetry. This line is called axis of symmetry. Okay, this line is called the axis of symmetry. This line again is another axis of symmetry. This line is the third axis of symmetry. Now, if you are taught about like this is a point, if you know a little bit of geometry, or if it is taught in your fifth standard, you will see around a point it is always 360-degree. This is 360-degree. You start from here, go and go here, come back to here. It is a 360-degree. So the one complete rotation is always a 360-degree. Okay, I hope you have learned it in your previous classes. So let me just wipe this thing. I don't need it right now anymore. Let's deal with this thing right now. Okay, so if this is the center, this is the center. Okay, let this be a line, this be a line, this be a line. Okay, so for this triangle, okay, if you rotate it like this way, you will get back exactly the same result as before. See again, it was this. When you rotated this, can you distinguish anything? I don't think so you can distinguish anything, but it is rotated by certain angle. Okay, again if I take this again, uh, if If I again rotate it, you will get another triangle which is exactly same. You cannot distinguish it, okay, from the ones before. You cannot if you see the image of it. Now again, if you rotate it, see, you will get back to the original position where it was. So you did three operations, once this, then this, and then this, to one get back to the original stuff. Okay, so each operation you perform, one, this, is you're rotating it by a certain angle. Okay, let I hope that you know what is an angle in a around a point, and like this thing, this is called an angle. I hope you don't know it. If you don't, please mention me. I will teach you that later. Okay, you're rotating it by this angle. As a result, you are getting it back. Again, you're rotating it. You're getting that thing back. Now again, you rotate it. You're getting the original thing back. So you perform three operations. So in three ways, for a given triangle, for this equilateral triangle, in three ways, by rotating it, you can get back some result which is exactly same as the initial one. So that's why it has now three ways you can show it symmetrical, like you get symmetrical result. So this rotation by the angle which you rotate, this angle is called the angle of symmetry. It means that how much you have to rotate so that you can get a similar, exactly same result as the initial one. Okay, now there are two other types of symmetry which I will tell you later. Let's learn the basics right now. Okay, let's go to a different shape right now. Now before that, since you have learned this thing, so what is symmetry? You can So what is the basic understanding of symmetry? It cannot be like that. You cannot define it like that. A mirror is placed, it is perfectly, its image is perfectly exactly as the initial thing, initial triangle. We cannot define it like that. So symmetry can be defined in this way. It can be defined that you do a bunch of operations. So you know, plus, minus, multiply, and divide. These are operations. Let's say you're given with a number x. Let's say 20. You add something, then it's an operation. You subtract something. That subtraction is an operation. Multiply, it's an operation. Divide, it's an operation too. So symmetry is something which says that if something is given to you, let's take this triangle for instance. Something is given to you, you perform some operations, the result does not change that as the initial. What do I mean by result? What I mean by result is that after performing the operation, you end up with the same thing as the initial result, initial taken. Okay, same thing as the thing which is taken initially. For example, when you put a mirror in this line and see it from here, putting a mirror and seeing from here is an operation you have performed. It's you have done something, right, to the triangle. So after doing that, after seeing that, you will see that this is exact, you are getting the exact same thing. Similarly, after rotating it about this point by angle something, which I will tell you later, not now, you get back the original thing. So that is also operation, you performed, for which you get back the original thing. That is how you define symmetry. Now there are, now we think of different shapes. Now let's think of a different shape. Let's think of a let's take a different shape. Another triangle. Let's say an isosceles triangle. How about that? So then in this isosceles triangle are triangle whose two sides are same and one side is could be smaller or larger than the other two. So you cannot basically tell how it will gonna be. Okay, so could be smaller, could be larger, depending on how you take the triangle. Now if I draw a line, okay, so in this triangle, if you put a mirror through this line, okay, mirror through this line, you will and see it from here, okay, and see it from here, you will get the exact same thing as before, which means like if you put a mirror here, you will get this result. What we will see is this exact same thing, this triangle. Let me use technology. I do have technology. I will copy this thing, copy, yeah, and paste it. Let me use a rubber. Yes, after looking through the mirror here, okay, let me use this and this. This is the mirror. What will you see? You will see this figure. If you have doubt, use a mirror, cut out an equilateral triangle or isosceles triangle, and you use a mirror and draw the mirror, like place the mirror here, and you will see, you will get this result. Okay, now so can we express it in any other way? Can we show the axis in any other way? Axis of symmetry, is there any other axis of symmetry? I think there is none, because if you place here, one side is smaller and one side is larger, so you will get not the exact same result again through here. No. So for this shape there is only one axis of symmetry, which is this line. Okay, now let's talk about the angle of symmetry. So if we rotate, and again rotate, we find out that after a complete rotation, then only we get back to the original thing, original shape. So there is one angle of symmetry. So therefore, there are two types of symmetry, one axis of symmetry and one angle of symmetry for this shape. Okay, let's take a very interesting shape, I suppose. And one of the most symmetrical shape in the universe. So if you ask me, what is the how many axes of symmetry and how many angle of symmetry are there. Let's find out. You can do it. So what we have learned is that axis of symmetry is a line where if we place a mirror, we will get back the original shape after looking at the mirror from a side view. Okay, so if I draw a line, let this be the center. Okay, center of the circle. If we draw a line here, this is a diameter. If you, I don't think so you have learned about diameter yet, but this line is called diameter, which passes through the center from a point on the circle, from 2 points on the circle. This is called a diameter. If you don't know, then it's okay. I will teach you later. So if you place a mirror here, wait, let me rub it. Okay, I can undo it. Let me just copy this shape first now. I will need it for your later understanding. Copy, and then I will paste it here. Let me use my rubber. Okay, you know what, leave it. I will create another shape. Yeah, this will be okay. Yes, I don't need this thing. So if you look through this, if you place a mirror through this line and see it from here, you will get this, you will see this thing. Now if you ask me how many ways can we uh, place a mirror to get back this original shape, I would say infinity. And I hope so you also know that it's infinity. Infinity, if you don't know what is infinity, infinity is a concept which tells you that there are unlimited amount of things. So in this way, in this case, there are unlimited amount of ways in which you can place the mirror so that you will get back this original circle. You can draw a line through line here, you can place a mirror here and see it from here. Again, you can place a mirror here and see it from here, so you will get back this. So, and why infinity? Because through a point, infinite number of lines can pass through it, so that's why it's infinity. Okay, and now if you ask me what is the angle of symmetry, that's also very interesting. Let me take this thing now. Now if you take this circle, so you would ask, in how many possible orientation can we express its symmetry? Okay, let me just draw a line for you, okay, so that you can understand that the circle is rotating. Let this be the line passing through the center of the circle. Okay, so now while understanding, ignore the line. Okay, if you count the line, you will get only one way to express this, two ways to express this symmetry, not one way, two ways. So I mean, why two ways I will tell you later, but for now let's focus on this thing. So see this, ignore the lines. Okay, I'm moving a little bit, moving a little bit, moving a little bit, moving a little bit. Just focus on the circle, don't on the line or the like this hitboxes or whatever it is called. You'll see I'm moving little bit, but you will not be able to understand it's moving when you see the line, see the circle, the circumference of the circle. Okay, so and I'm moving a little bit every time. I'm moving a little bit. So from there you can tell that there are infinite angles of symmetry. Let's say you know the concept of degree. I'm moving it 1 degree. You cannot distinguish. If I move it 0.00001 degree, you also cannot distinguish. And you know that number in between two numbers, 1 and 2, there are infinite such small numbers like 1.1, 1.01 in decimal places. So angles having magnitude of like having values of 0.01, it's very small, but it is rotating by it. So you can express that there are infinite angles of symmetry. So I hope you understand a little bit of concept of symmetry. Like I gave you the understanding what is symmetry is, how you can express an object is symmetrical, how you can show its axis of symmetry and its angle of symmetry. I've shown you that. Well, if you have any problems after watching this thing, tell me for sure, and DMs or whatever, or in the comment, whatever you want, wherever you want. Okay, then according to your problem I will give a counter solution to that. Okay, bye, peace out.